Open up. Let's see. Dropbox, DIFC. Hey. Workbooks, physics, mechanics, lecture 17. Okie dokie. Conservation of energy. Ready? George? Got that? Yep. Okay. Some people probably have heard of this before. Have you heard of this before? Do you know what it is? Tough marks. But for the people who don't know, could you explain that? That's better, yeah, just don't use the word conserved again. The same, yeah, the energy is the same. So, let's see exactly what that means. So anyways, before we get on to that, what exactly is energy? That is, if something has energy or is energy, then what do we mean? So what exactly do we mean when we say something has energy? Well, in physics, when we say something has energy, what we're really just saying is that it has the ability to do work. So, if that drink has energy, it has the ability to do work. Or if you have energy, you have the ability to do work. Or if the batteries here, if they have energy, they have the ability to do work. So in other words, having energy means you can do work. This is the physics definition of work, and you should write that down. In physics, something has or is energy if it has the ability to do work. Got that? Yeah? Now, this is also measured in joules. So let me just be a little bit clearer. No work means no energy. No energy means no work. So they go together. If you can't do work, you have no energy. And if you have no energy, you can't do work. Okay? But the work done is always less than or equal to the energy available to do work. Of course, this makes sense. You know, you can't do more work than the energy you have to do the work. You know, this battery won't last for 100 years. It can only do the work equal to the energy it has, or less. So, for example, let's say if I have 1 megajoule of energy, then I can do up to 1 megajoule of work. Often for the problems we look at, all the energy is used. So often we find that the work equals energy. So usually all of the energy in the story is used for work. So most of the time the work equals the energy. But just so you know, it doesn't have to equal. You know, the work could be less than the energy and then you have something left over. You know, it's like if you drive your car. You could use all the fuel, but usually there's a little bit left at the end. Okay. You don't have to write really that down. Once you have the definition, that's kind of enough. Okay, let's continue. If, I should Right, so, key thing now about this lesson. There are many types of energy. That is, there are many types of things that can do work. Too many quotation marks. There are many types of things that can do work. So let's have a look at the types of energy. So, what things can do work? So I need you to write this list down. So the first thing is the obvious one. Electrical energy. Obviously electricity can do work. It's doing work right now. The electricity is making the TV work. It's making the laptop work. The electricity in the other room makes the room hot, makes the heaters work, makes the lights work. So obviously the electrical energy is a very common form of energy. Okay, is that okay? Electrical energy. Right, next form of energy. Magnetic energy. Now what type of work is this magnet doing? Well, it's lifting up the metal. It's like it's like when the father lifted the child. The father was doing work. So the magnet is doing work. It's a magnetic energy. Yeah? Okay, so the next one now. The most delicious form of energy. I mean, these two don't taste nice, but this type of energy tastes nice. It's chemical energy. The type of energy you get in your food. A rather important form of energy. Right? Because we're not plants. You know, we don't get our energy from the sun. So chemical energy. Now, this is the plants, the radiant energy, the energy from the sunlight. This is where plants get their energy from. Now, that's not completely true. I'm sure some plants get their energy from maybe the ground. Maybe it can take something out of the earth, I don't know. And some plants actually eat flies, I know. Fly trap plants. But most plants, like grass or something, would just be from the sun. Does anybody remember it from biology what this is called in biology when you take energy from the sun?
Photosynthesis.
Photosynthesis, yeah. If you studied biology before. Also, this is important for who's got the Casio 991 calculator? Ah, you do. Now, look at this. This gets energy from the sun, right here. It gets energy from the sun.
If I lock it up a little bit more.
It might have a backup battery. Does this one have a solar panel? Oh, it does, yeah. Turn it on and cover that with your finger and see how long it takes to turn off.
How do you turn it off?
Is it on?
Yeah.
And is it still powered?
Okay.
It's still on? Yeah? Okay, it must have a backup battery. I'd imagine most solar panels would need a backup battery for when it's dark. You know. Okay. Next one is nuclear energy. Whose home country has nuclear power? Let's see. China. China has nuclear. South Korea has nuclear power. Malaysia? No. No nuclear power. No.
We don't have that good scientists.
Oh, really? George, what's your home country? Nuclear? No. Probably not allowed to, right? What else? What's your home country? No. I wouldn't have thought so, right?
No.
Oh, goodness, no. Just too small. It wouldn't make sense, you know. It's not big enough. Like you would need to have these big cities like London or Paris, and then maybe you could have a nuclear power. Seoul, you know, Beijing, you know, these places would need nuclear power, but I mean, not Dublin. You know. Okay. The next one, that was an interesting one from chemistry. Ionization energy. You've done ionization in chemistry, right? So you know that to release an electron, you need to give it energy. So there's an energy inside the electron, the ionization energy, an energy level. We'll actually study this in semester 2. Continue. Next one. Interesting one. Elastic energy. Like in the toy. Yeah. This is actually an important energy in biology and physics, but in biology, because a lot of things in your body will be elastic. You know, they would have a stretch to it, and the stretch might even be doing some work. So, like for example, as I'm speaking, I'm sure there's something being stretched that's doing the work of making the sound, or the muscles, perhaps. Gravitational energy. So you can see the sun is pulling planets. So, gravitational energy. Okay, a few more. Heat energy. Okay. Obvious one. This one, mechanical energy. The energy in a mechanical system, like the picture here, like a clock. You know, you can wind the clock, and the energy, it slowly does work. It slowly moves the hands. It's a mechanical stored energy. Obviously less important nowadays, but still very important in physics and engineering. Okay. I suppose this type of energy is really important for people designing cars, because you still need to think a lot about gearing and things like this. Wave energy. Now this is actually a very important form of energy in Ireland, because there's the possibility that Ireland could produce its own energy completely from wave energy, because the west coast of Ireland gets a lot of wave energy from the Atlantic. In fact, the west coast of Ireland gets the third most wave energy in the world. There's only 2 other places that get more wave energy. So it's possible that you could take all the wave energy from the west coast and use it in Ireland, and even export it to the rest of Europe. Okay, so this obviously would be a good green energy. Ireland uses too much fossil fuels. Too many fossil fuels are used in Ireland. Most power is from fossil fuels. Kinetic energy is next. So kinetic energy is the energy something has because it's moving. A movement energy. Yeah? Next one is potential energy. So this is the energy something has because it can do work. So this rock here, it has energy in it because it could do work. The work it could do is kill him. So this work is stored in it, like contained inside, ready to be released. A potential energy. Yeah? Right, so we've looked at all these forms of energy, and what the most amazing thing is something called the conservation of energy. Now, I'll say this a couple of times to emphasize the importance. This is the most important rule in physics. Did you get that? Of everything in physics, high school physics, university physics, baby physics, this is the most important. There is not a more important rule in physics than this. And the reason that it's so important is because it's true. It's true at every single level of physics. So if you're doing simple physics at high school, you're doing advanced physics, you're doing research physics, you're doing physics about planets, the universe. This is true at every level. The most important rule in physics. And it says that energy cannot be created or destroyed, but it transforms itself from one form to another. So you can't make energy. You can't destroy energy. All you can do is take it from one form into another form. So for example, here, this is electrical energy. I did not destroy it. Instead, I took the electrical energy and made light energy, made sound energy, made heat energy, but it's still the same amount of electrical energy. Okay? So when I eat food, I don't destroy the energy in the food. I just change it into work that I do. Okay? Or when a plant takes energy from the sun, it doesn't destroy the energy, it just changes it into making the plant grow. So a kinetic energy.
So it should be plants, right? Energy can't be.
What did I write? Energy can be, well, no, actually, because I used the word neither, it's grammatically okay. I say energy can be neither created nor destroyed, but it transforms from one form to another. Yeah. So obviously nuclear energy gets changed into electrical energy, and then if that goes into your home, that electrical energy could change into heat energy. You get that? Yeah?
Then heat energy for what?
Well, when you heat your room, the heat energy stays as heat energy, but it dissipates, it leaves the room and goes into the environment. So you can't feel the heat anymore because, not because it's gone, but because it's spread over such a great area, you don't notice it. You know, you think about my sound energy. Like if I shout really loud, will they hear me in the mountains? No. It doesn't mean my sound energy is gone. It's just, it gets spread out over such a big area, you can't pick it up. But if you had a machine powerful enough, you could still pick it up. Okay, you got this? Yeah. So, yeah, here's just a small question for us to do. So if you were to sit up and sit down, you've done some work, you've moved yourself up, okay? Where did that, okay, so what type of energy is this? This is kinetic energy. Where did that energy come from?
Potential.
Yeah, where did that, like potential inside me perhaps. So where did that come from? Yeah, where did that come from? Where did I get mechanical energy from? Yeah, well suppose I had for breakfast bacon and sausage I had for breakfast. Where did my energy come from? Well, it came from bacon and sausage. Well, where did that energy come from? No. Yeah. Not from the heat that was put into it.
From the pig?
From the pig, yeah. Where did that energy come from?
And the energy
from the pig's food.
Yeah.
Say oats. Where did that energy come from? Well, the oats grew in the ground. So where did the oats in the ground get its energy from? The sun. Okay. So the point I want to make is, when you really think about it, all the energy we ultimately get on Earth is from the sun. Okay? So we might think, oh no, I get my energy from plants. I'm like, well, where do they get from? The sun. So, oh no, I got my energy because I ate a cow. Well, where did that get energy from? From eating grass. Where did the grass get its energy from? From the sun. So every type of energy, like even fossil fuels. Okay? What are fossil fuels? What are they? They're basically dead animals. So where did the dead animals get their energy from the sun? Do you understand what I'm saying? Like every form of energy ultimately comes from the sun. Okay. Now the real question you need to start thinking about then is, where did the sun get its energy from? But I'll let you think about that. It's just enough for me to say that on Earth ultimately all energy comes from the sun. That's where our source is. Okay. So not a difficult lesson, just kind of a thinking lesson about these different ideas. So there's a few simple enough questions here for you to do. Right, you got a few minutes. I don't think it'll take you long to do. So yeah, If you take 10 minutes to do this and then we can finish, okay? They're nice little word questions.